Hello, my name is Mohammed Badruddin and I'm here to talk about the strain gauge or load cell. This is for ECE 109, section E01. Definition: what is a strain gauge or load cell? A load cell, it is a transducer which is used to create an electrical signal with a magnitude that is directly proportional to the force. Strain gauge. It is a force sensor and a transducer. It needs to be conditioned to have an output reading. The conditioning may include amplification, attenuation, excitation, filtering, and isolation. Principle: it senses an applied load or force weight, and then it changes it into an electrical signal output that is proportional to the load. The output electrical signal is very small, usually in millivolts or volts. Electrical strain gauges are based on the principle of changing the electrical resistance due to the change in the length of the metal used in the strain gauge. The formula for the resistance of a strain gauge metal is R is equal to P multiplied by L over A. Well, R is the strain gauge metal resistance. P is the specific resistance of a strain gauge. L would be the strain gauge length, and A would be its cross-sectional area. Additional information: the strain gauge, which is the sensitive element in the load cell. It is a bonded resistive foil sensor which is capable of stretching and contracting. Its resistance varies with the applied load. The material deforms or stretches and contracts. The strain gauges are mounted in areas that exhibit strain and compression or tension. Most strain gauges are made from copper-nickel alloys. The alloy metal is cut into zigzag foils to form the strain gauge. Other basic elements that make up a strain gauge load cell includes the spring element, the sealing elements, and the housing that helps protect the load cell components. Configurations: the strain gauge load cell is made out of strain gauges that are electrically connected in a whetstone bridge. The whetstone bridge can be of different configurations. It can be either in the half bridge, the full bridge, or the quarter bridge. Types of strain gauges load cell. The shear beam. It's a straight block of material fixed on one end and loaded on the other. Bending beam. It's compact, extremely versatile load cell that can easily fit into the components where space is limited. Pancake. A low-profile compression and wheel tension load cell. It has a wide surface area for absorbing shock loads. Single point or platform load cells. They allow the construction of a weighing scale or machine with only one load cell. It is used in small sized or medium-sized platform scales. A double-ended shear beam. The straight block of material fixed at both ends and loaded at the center. Compression load cell. A block of material designed to be loaded at one point or area of compression. The S-type load cell, a S-shaped block of material that can be used in both compression and tension. Rope clamps, an assembly attached to a rope and measures its tension. Rope clamps are popular in hoists. Load pin, it is used for sensing loads, example, axles. Advantages and disadvantages. Advantages. It doesn't have a moving point. It is small and inexpensive. It has a fast response time. The ease for compensation for temperature effects. Its relative freedom from acceleration effects. Now, disadvantages. It has to be placed in deformation spots only. Overloading may cause mechanical damage to the sensing element. Wiring may cause high resistance due to corrosion over time. It can be damaged by conducted current and high voltages that can break through its insulation. It is non-linear and it is sensitive to vibrations. Applications. Strain gauges may be used in smart bridge technology to detect structural problems early. Strain gauges measure aerospace phenomena like wing deflection. Monitoring bridge cables with strain gauges. Rail monitoring with strain gauges. Torque and power measurements in rotating equipments. That's all, folks. Thank you for listening.